Welcome to the second week of the course on recommender system. So far we have been talking about the data part of the recommender system literature. So, continuing in this, we have seen in last week we have discussed about the data collection methodology, we have discussed about different measurement scales. We also saw how to get certain initial insights about the data, considering it in the univariate form as well as considering their bivariate relationships. So, now we are going ahead and trying to get little bit more understanding about the data before we actually go for statistical and machine learning foundations. So, this is the first step towards this foundation building. So, moving ahead, here we will be talking only on different data preprocessing techniques. So, when we talk about the data preprocessing, it is a part of data preparation. So, before you adopt any machine learning algorithms, you have to prepare the data so that it is suitable for that particular algorithm. So, data in real world has many problems, sometimes this is incomplete. So, of course, the problem in recommender system that you are trying to solve is about how to impute these values of ratings, how to predict this rating. So, basically those data is missing. So, this is one example of incomplete data with the problem that you are trying to solve in recommender system. Besides this, the data can be noisy. Noisy in the sense, if somebody's salary is let us say 10 rupees or age is 222, which are quite impossible. Data can be inconsistent as well. For example, the age of a person is 42 years, but the birthday turned out to be 1997, which means it is fairly impossible. Sometimes the data need to be formatted for a given software tool or algorithm. For example, if you are talking about let us say decision tree, your data needs to be discrete. So, therefore, even if you have the data in terms of let us say interval or ratio scale, which is continuous quantitative scales, you have to now discretize it. Okay. So, this because of this software tool and a method also, we have to do some kind of modification for the data to prepare it for the algorithm. So, these are the major tasks under preprocessing: data discretization, which is about reducing the data in the form of discrete values, which is derived from the numerical form. The example that I continue with the example that I gave you, if we have age of a person in the age of the customers in the store, maybe you can categorize, instead of considering the age as a continuous variable, we discretize it and maybe we can make the groups such as young adult, young, middle aged, then you can say middle aged, old, then old and so on. Then the task is data cleaning. It is about filling in the missing values, taking care of the noisy data, removing outliers, resolving inconsistencies and so on. Next comes data integration. When the data comes from multiple databases or has multiple dimensions, we have to combine them and represent them in a form so that it becomes usable by the algorithm again. Then comes the data normal transformation. Here we have to normalize the data and maybe we have to aggregate the data from multiple sources. And finally, we have data reduction. It is about reducing the data in a manner. See, data consists of a number of rows and a number of columns. Rows basically represent entities and columns represent the features. So, it may so happen that you want to reduce the number of features. So, that is column wise you will be reducing. Maybe you will be removing some of the unimportant features, or you will be representing the data in a latent feature space. So, that with less number of features you will be characterizing maximum amount of information. Similarly, row wise also you may reduce, and why this row wise reduction is necessary? That this process is called sampling. So, out of all the elements that you have, all the entities that you have, only partially you consider them for your algorithm. Why this has to be done? This has to be done in the initial stage when you are trying to figure out which algorithm is the best. Let us say you are considering 4 algorithms for your work. How will those algorithms work? You don't, to save time, probably you won't be using the entire data set. You will be using a representative part which is a subset of this data set. That way also you have to reduce the data. So, data reduction, though typically is concerned with reducing the number of features, sampling can also be termed as data reduction, in the sense selecting very less number of representative entities for testing the algorithms. Now, comes to the discretization of continuous variable. It is about dividing the range of a continuous attribute into intervals. There are many methods to discretize this, and the techniques such as naive Bayes etc. require such kind of discretization. Many times this is also useful for generating a summary of the data. How it is done, this discretization? Discretization can be done in many ways, but one of the ways specifically for the numeric data is making the bins. Bins in the sense you have, let us say, many data points D1, D2 and let us say some dm number of data points. Now, what you do? You have to, this is in continuous scale, you have to bring them, group them together so that they can put together in one bin. So, this bin can be of two types, in equal width bin. In case of equal width bin, let us say your total range is between 10 to 100 and you would like to make some 5 bins out of it. So, this entire range which is from 10 to 100, which consists of let us say 90 different possible values, I mean the 90, I mean the between 10 to 100 there can be many values of course. Let us say you put them into 5 bins. So, if you put them into 5 bins of equal width and total, let us say you can keep something, I mean following certain procedure, you can let us say starting from 10 to 20 you can put in one bin, from 20 to 30 you can put another bin, and I mean 20 plus and 30 you can put another bin, and so on. Similarly, 90 to 100 you can put another bin. So, how many bins you have made? Total 9 bins you have made, and in case you have to make 5 bins, of course, this range you are supposed to increase for individually. Next comes your equal height bins. It may so happen that here there are very few people in this range. Let us say there are only 2 people here, 10 people here, and let us say this here again you have some one person, in between there is another range where you have let us say 100 people. So, height of all these, if we consider the frequency of items in each of these, it is going to be different. So, it may so happen that you are interested to, in each group you are interested to consider same number of people. So, in that case probably you do not have to make this interval equal in terms of this range, rather in terms of height. So, to make let us say the age groups when we make of equal heights, so this is frequency and this is let us say your age groups. Okay. So, it will turn out that to when you try making them equal height, maybe here you have some 10 to 30, here you have 30 to 40, here you have 40 to 60 and so on. So, this range which was same here is now different. So, you can make equal width binning or equal height binning. Okay. So, now this is little bit more about equal width binning. So, in case of equal width binning, suppose you would like to make a bin, number of bins to be n. So, this is the highest value, this is the lowest value and this is you divide. So, in the last example when the highest value was 100 and lowest value was 10 and we wanted to make as 5 bins, this is the number of bins and this is the, based on this you have to decide your interval. So, in case you have to have equal height binning, you have to divide the range into n intervals, each containing approximately the same number of sample. Generally, it is preferred to avoid clumping of the data in a particular bin, as I told you. Then comes the next task of preprocessing, data cleaning. Missing value, of course, we are trying to solve the problem of predicting the ratings which are missing. So, in that case of course, we cannot ignore, okay. But suppose in case of let us say customer details, some of the values are missing, then what do? Most of the values are available. So, you can ignore it, you can mark another value as a new class for this, let us say call it unknown. So, this just becomes another nominal variable. If it is a continuous one, you can change it with attribute mean and you can sometimes do replace it with certain most probable value depending on some inference that you make. Then you can, another issue that comes during data cleaning is to identify the outliers and smooth the noisy data. And we saw that finding the outliers, while finding the outliers in case of univariate method, how to find the outliers using the box plot etc. Similarly, you can use other methods as well. And once you correct this, you have to look for inconsistent data, that I saw one example earlier. Somebody's birthday was 24, birthday was in sorry, birth date was in 1997 and age was 24. So, similarly, redundancy you have, that is caused by data integrity, can also data integration can has to be avoided as well. So, this is what I told you. You avoid the outliers using these box plots, and extreme outliers are thing which are beyond 3 times the away from the first quartile and 3 times away 3 times IQR value away from the first quartile, or beyond third quartile 3 times IQR value. but you also have certain mild outliers which can be in this range. Okay. So, using this formula you can, this figure is also not necessary, using this formula you can remove the outliers. You can make certain observation of the outlier if you look the univariate distribution and find out something which is quite away, okay, that can be on some outlier. There are many statistical methods for detecting outlier in multivariate data. So, even if we are considering univariate outlier, sometimes this can be misleading. For example, if somebody's age is 10 or below, he is likely to watch kid movies. Now, if only few such people are there, you cannot call them as outliers. This is a specific group and their viewing pattern is associated with their age. So, therefore, multiple variables together can give you this detail. Okay. So, one such multivariate outlier detection method is using something called Mahalanobis distance. Mahalanobis distance. Okay. So, higher this distance, you say more probable is that the point is an outlier. Here in this formula, this is your covariance matrix, this is the average values of the data and xi is the data element. When I say data element again will have a number of attributes. Okay. So, taking all the attributes together, you make this covariance matrix. Okay. So, when you make this covariance matrix, n is the number of attributes and over all the attributes you make this. There are many data mining methods using certain distance based measure. If you find an observation is defined as a distance based on outlier, if it is at least a fraction beta, if at least a fraction beta of this observation in the data set are farther than r from it. So, some such heuristics you can make. This is basically heuristics based method. There are many one class classifiers in which you try making one class consisting of the data, whatever is outside that class you consider them as outlier. See, similarly, you have clustering based methods. In clustering, typically a small side cluster you may consider as an outlier, but it may be a misleading situation. You have to be actually going through further detail to explore why such a thing has happened, but such small clusters sometimes are considered outlier compared to the larger clusters. But the example that I was telling, if there are very few movie viewers who are watching let us say kids movies, then they cannot be considered as outliers. They are supposed to be a different class of viewers altogether. Their number may be small, but putting them together in the analysis along with adult viewers may lead to misleading results. So, therefore, you may consider them as outlier when you cluster the data, but that cluster needs special attention. Maybe you are supposed to deal with that cluster with in a different manner and run a separate algorithm for that. Now, next task is handling missing values. So, when it comes to handling missing values, these missing values can be more in one record. See, after all, we are considering the data where we have the entities here and attributes here. Okay. So, let us say we have one entity in which most of the values are missing, only 2 values are there, then we may drop this entity completely. Similarly, there is one attribute column where nobody has given any data. So, that attribute you may think of dropping. Okay? But usually when you ignore the records or ignore the columns completely, because very less number of values are present, you may also be missing some information. Okay? So, therefore, while taking these decisions also you have to be little careful. So, data description actually comes to rescue when such kind of situations arise. So, you can also fill on these missing values manually if necessary, but that is a tedious task. So, you have to have some kind of algorithms for this purpose. Okay. So, how do you handle missing values? You can use a global constant to fill in the missing value, use the attribute mean to fill in the missing value. Use the attribute mean for all sample belonging to the same class to fill in the missing value. Same class in the sense, suppose you have clustered it, you know that for average age of all the young, when you categorize the data into young, young adult and so on, use the most probable value in the missing place. So, when you use the most probable value in the missing place, you can use certain information in inference based mechanisms like using some kind of Bayesian formula or decision tree, identifying the relation. As we go ahead, we will be knowing more about this Bayesian methods, decision tree, etc. At least if not in depth, we will have overview of all category of machine learning algorithms that are typically used. So, some such algorithms can also be used to handle the missing data problems. Then next is your data integration. When it comes to data integration, once again data has columns and data has rows. Schema basically represents the columns. So, when you get data from multiple sources, it may so happen there are common columns. So, you have to be really careful while merging. You should not be replicating the same column again and again. So, similarly, there can be, when you collect the data and try integrating, there can be row replication of row itself. So, again you have, that has to be taken care of. Okay. So, while detecting this, resolving these data value conflicts, it may happen because some of the real world entities and attribute values they derive from different sources may be different. For example, in some source the data is represented in metric unit and in some in British unit. So, in that sense same data can have different form. Then data transformation. Data transformation again is about smoothing the data and removing the noise. So, this can be done by binning, regression method and clustering. Or you can aggregate the value, which is about summarizing from the data cubes. You can make generalization using concept hierarchy. You can have attribute or feature construction by combining more than one attribute, or you can normalize. So, let us look at how do we normalize this data. So, there can be various ways in which you normalize, and why this normalization is necessary, because many times if the data attribute in one attribute has very small values, let us say in terms of fractions, let us say between 0 to 1, and other one has the value in terms of millions, then the algorithm that to which you are feeding this data may end up making some kind of numerical errors which is undesirable. So, therefore, probably you would like to bring the data almost into the same range, let us say from 0 to 1. So, there are various ways you can do it. You can do minimax normalization, in which following this formula, in which you will be putting the value, you will be bringing the value to certain maximum and minimum defined by you. There can be certain z score normalization, in which you will be following the, you will assume that it follows the normal distribution, and from the data you will be subtracting the mean and divide by standard deviation. Then you can also normalize the data by decimal scaling. So, as I was telling, let us say some value is in fractions, let us say 0.00001 or something, another value is in 10 to the power something. Then if you divide the higher value with this, then probably you will be bringing it to the same scale. This data reduction can happen by aggregating the values in the data cube, by selecting a subset of the attributes, by reducing the numerosity and reducing the dimensionality. As we move ahead, we are going to look at all this. So, this is one example of data cube aggregation. In case of data cube aggregation, as you see here, in this data cube you have quarter wise cells in each year, quarter wise cells in each year, first year, second year, third year. Now, we have to combine them together. So, instead of representing it in quarter level, we will be representing it in terms of years. So, how do we come to years? We will be combining this data together and represent in terms of year, combining this data together, add this together and represent in terms of year. So, this is how we reduce the data, by aggregating from the data cube. You can also reduce the data through certain attribute subset selection procedure. This is just one example of attribute subset selection procedure. There are many other ways. Forward selection, in which you will be using one attribute at a time to run the model, then add second attribute, then add more number of attributes, you keep on adding till you find there is no improvement in result by adding additional attributes. Similarly, you start your process from taking all the attributes together and you keep eliminating till you end up getting the minimum number of attributes, which gives you good result. You can use decision tree induction as well. Suppose from your data you find out, while making a decision tree, you find out that in the nodes only A1, A4 and A6 are existing. Rest A3, A5 and A6 are becoming irrelevant when we tried making this decision tree for classification process. So, therefore, we can keep these 3 attributes as important and drop remaining attributes. Okay. For numerosity reduction, again there are various methods. It can be either parametric or it can be non-parametric. By parametric we mean to say, we assume the data fits certain distribution and parameter of that distribution we use in some sense for reducing the numerosity. In case of non-parametric method, no such distributional assumption is made. So, histogram clustering, sampling etc. can be used for this purpose. Now, discretization and concept hierarchy generation, when we talk about this, we look at the raw data and try aggregating it at a higher conceptual level. So, this is one example of a parametric method, specifically here regression is used. So, what can be done? Let us say these are your data points, but your regression line provides you certain average behavior. So, instead of presenting this data at this point, corresponding point here we can represent. For this data we can have this point, for this data we can have this point. So, all this basically will be representing on the regression line, that is how the variability will among the data points will actually decrease. In case of non-parametric method, as I told you, we can have let us say some binning approach, in which let us say 1 to 10, this is 11 to 20, this is 21 to 30. So, this one can be represented as one group, let us say group 1, this will be group 2, this will be group 3 and so on. Similarly, when we cluster, we can have distinct clusters, let us say this can we talk it at group 1, this is group 2, this is group 3. So, this is how so many data points will be represented by only 3 values. So, all these data points with here let us say frequency is around 13 or so. So, all these 13 elements will be represented by 1, here all the 25 elements will be represented by 2 and so on. So, this is how also you reduce numerosity, and this is again generalizing certain value to a higher conceptual level. For example, suppose in a non-numeric nominal scale, you have something represented, laptops represented as IBM or something else, desktops with Dell and other companies, office software with Microsoft and other thing. So, therefore, these are a little more generalized in hierarchy, concept hierarchy. So, in this concept hierarchy, let us say mouse from various agencies can be put together and termed as mouse. Similarly, wrist pad, mouse, etc., and all other computer accessories can put together. If you want to further reduce the numerosity, you can have this thing. So, at this level you have 4 different categories, 1, 2. So, you can have 1, 2, 3 and 4 to represent 4 categories. At this level if you go, you have 1, 2, 3, 4, 5, 6, 7, 8 categories. So, in the data when you replace laptop, you replace it 1, desktop with 2, office with 3, antivirus with 4 and so on. This is the case of when you have a non-numeric data, which is basically nominal, in nominal scale. In a continuous scale also you can reduce in the similar manner. For example, here you have taken you have discretized it and your range here is 1 to 100, this is 100 to 200 and so on. So, this 1 to 100 if you want to, so here how many numbers you will be using for this is group 1, group 2, group 3, group 4. So, you will have total 8 groups, but if you want to reduce this numerosity further, both these together you can call as group 1, this is group 2. So, you will have 4 groups together, and if you want to further reduce, probably only one group, and probably you will not be doing, because otherwise everywhere this will be 1 and this the variable will become not so useful. Sampling can be another procedure. Now, here when we talk about the sampling, we consider it in two senses. For reducing the data, size of the data, specifically when we are at a stage where we are trying to figure out what is a good algorithm, probably we will try to reduce the number of entities. So, when you reduce the number of entities, we can sample. So, when you sample, there are various procedures for sampling. Here this is one example of a random sampling with and without replacement. In case of look at this here 5, I mean that this transaction 5, transaction 1, 8 and 6 each occur only once. So, which means once they are sampled, they need not be considered again. Once they come to the sample set, they need not be considered again. And here T4 appears twice. So, which means once it is sampled, but it was put back. So, it was with replacement, this was without replacement. Okay. So, similarly, there can be something called stratified sampling. In case of stratified, let us say this is stratified according to age. So, this is the first strata, second strata, third strata. So, out of that you will be choosing, let us say from youth you have chosen 2 people, from middle age you have chosen 4, from senior citizen you have chosen 1, and so on. You cluster this in certain manner, and from each cluster represent each cluster. Why they are clustered? Because they belong to one cluster, because they have certain common characteristics. So, from each cluster you choose few. Okay. Similarly, this process can also be used to reduce the numerosity. Numerosity in the sense, let us say cluster 1, all the elements will have certain value, but let us say all the youth will have certain age, but ultimately they will be represented by youth only. Okay. Now comes to the dimensionality reduction. Now coming to this dimensionality reduction, there are many ways in which you can do it. First one is your principal component analysis, in which instead of using all the features, you combine the features, take a linear combination of the features and present only top few features which explains maximum variability in the data. And those features which you create by linear combination of other features, we can call them as some kind of latent features which we discovered from the original data. Similarly, you can have matrix decomposition approaches like singular value decomposition, where again you can discover latent features, and only few latent features you take. I mean, it depends on the rank of the matrix. So, you make a low rank approximation of the matrix, and then comes your signal processing techniques like that of, let us say your input is let us say some song. So, you can consider the Fourier transform, discrete Fourier transform, and take top few components. Okay. So, with this we finish this one. These are my references again, and most of these that I covered here are from this Han and Camber data mining book. And to summarize, data processing is an important part for improving the stability of the algorithms. Data discretization, cleaning, integration, transformation and reduction are the broad category of preprocessing. Discretization of the continuous variable can be done by dividing the range of the continuous variable into intervals using binning. The task on the data cleaning are missing value estimation, outlier removal, etc. Data integration deals with schema integration and detecting and resolving the data value conflicts. Data transformation involves the tasks such as smoothing, aggregation, generalization, attribute or feature construction and normalization. Data reduction involves the tasks such as data cube aggregation, attribute subset selection, dimensionality reduction and numerosity reduction. Thank you.